Hello and welcome to our finance section on compound interest. Last video, we talked about simple interest, which is the most basic form of interest. But now we're going to talk about compound interest. And so here's a couple things we're going to look at. Let's first kind of explain what investment is. When we're investing, we're using money or capital for income or profit. And investments can be divided into two classes. We've got fixed investment, which is the amount invested as principal is guaranteed and the interest is compounded at a fixed rate. So a savings account, money market deposit accounts. Variable investments means that neither the principal nor the interest is guaranteed. So that would be, for example, stocks, mutual funds, things that have a lot of variability to them, sometimes throughout the day. But what we're going to look at then is more of a fixed investment right now. And we're going to look at compound interest. This basically means, so when we looked at simple interest, the interest was basically paid at the end of the loan. With compound interest, it's compounded, meaning it happens, this is going on over time and it accumulates interest. Instead of just the interest happening right at the end of the loan, the interest will continue to accumulate. Let's look at the formula. You have A, which means total amount, equals P is still your principal, times 1 plus R over N to the NT. Now, you have a new variable here, N. What is N? Well, N is, let me see, N, here we go. It's the number of times we compound. I was going to say annually, but I'm just going to say in a year because it's going to be per year. Number of times that we are compounding in a year, meaning if it's compounded monthly, N would be 12. Okay, so actually, let me give you some examples while we're here. If we're told that it's compounded monthly, then N would be 12. If it's yearly, well, that's 1 times a year, so N would be 1. If we're compounding, I'm thinking of another one that we might see a lot, quarterly, that would mean 4 times a year. And another common one I see is semi-annual, and that would equate to 2 times a year. So these are different numbers, just a few of the common ones that your N could end up being. But you look for keywords in the phrase or in the sentence to see. For example, let's go ahead and look at example 1. Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposits into this account, determine the amount in the savings account after 2 years. The word compounded automatically means that I'm going to be over here. We're not going to be using simple interest. I always write down my formula before I use it. That way I can get a chance to look at it, see what variables I need. Well, she's investing $3,000, so that means I have 3,000. Okay, then we have 1 plus. Now, our rate is 1.8%. Well, that's going to be 0.018 in my equation. All right, all over N. It says that it's being compounded monthly, so N is going to be 12. And then it's to the N times T. It says right here, 2 years. So I plug in 2. It looks like a complicated formula, but I promise you we're going to use the order of operations and it won't be as complicated as it may look. 1 step at a time. Order of operations says that we do exponent followed by parentheses. Now, we can do that part in 1 step. what we can do is we can go ahead and do this part, the inside the parentheses. Now, on your calculator, this is what I recommend. Take 0.018 divided by 12 first. Hit enter. Then add 1. It'll help from saving from calculation errors. If we do that, we should get, and again, remember, I don't always round soon. I'll go to 4 places. Now take 12 times 24, and I get to the 24th power. Okay, we're getting there. But order of operations says I need to do the exponent first. So do not multiply the 3,000 yet. You can't. You have to do the exponent first. That should be a 4. It looks more like a 9. Okay, in that case, that means I have 3,000. I'm not doing anything with that yet. Take 1.0015 to the 24th power. Okay, when you do that, and do this along with me so that you can double check to see what you're getting, but I'm writing this out as far as I can go, so that way I'm not rounding until the very end. At the very end, you're going to round this to the nearest cent, because we are talking in terms of dollars. We should get $3,109.88. Okay, so again, do the inside first of the parentheses, then do your exponent, but then you will multiply at the end with the 3,000. Let's try another example. Calculate the interest on $650 at 8% compounded semi-annually. And we talked about this, so that would mean N is 2, because that would be twice a year, for 3 years. So there's our T, and here's our R, written as a decimal. And here is our P. Okay. I write out my formula. So A equals P times 1 plus R over N. Honestly, the more you write this, you start to memorize it after a while. All right, so that would be, we have $650 that was invested, 1 plus our rate, which is 0.08, over 2, because remember it's compounded semi-annually, and then 2 times T, well, T was 3 up here. Again, I do my parentheses. So I'm going to take 0.08 divided by 2, hit enter, then add 1. We should get 1.04, but then we still have our exponent. 2 times 3 is 6. Next step, take 1.04 to the 6th power. Remember, we have to do that first before we multiply by the 650. And I'll show you, I'm just going to write this out as many decimal places as I was putting down here. Now you can multiply by the 650. And again, if you're doing this with me and I'm going too fast, just pause the video, because I want to make sure that you're getting your calculations, you're seeing them, because this chapter is where we get a lot of errors as we're punching in numbers. It's so easy to make a mistake. So, okay, $822.46. That's the total amount. That's not what the question asked. The question said, what's the interest? Well, remember, we're not calculating the interest. A always means the total amount. Well, we know how much she borrowed and we know how much she earned, so we can easily find the interest. Remember, we talked about this in our previous section, but what we're going to do to find the interest is take the total amount. Oops, let me just undo that one. There, minus the principal. In this case, I'm going to take $822.46 minus the principal, and that's going to tell how much was earned in interest, $172.46. All right, example 3. We've got 4 examples today. Will would like his daughter to attend college in 6 years when she finishes high school. Will would like to invest enough money in a certificate of deposit, or CD, now to pay for his daughter's college expenses. If Will estimates that he will need $30,000 in 6 years, how much should he invest now in a CD that has a rate of 2.5% compounded quarterly? This is a little different, isn't it? Because what is it asking us? It's asking us, how much should he invest? That's our P. This right here is our A. Okay, so we're going to actually be solving for a different variable this time. I'm still going to write down the formula. I always do. Okay, this time we have A. He wants the total amount to be $30,000. He wants to know how much needs to be invested quarterly. Okay, there's our other keyword here. Quarterly, that means N equals 4, right? 4 times a year. 1 plus our rate, 0.025. Don't forget to change that to a decimal. It's probably the most common mistake I see pretty much every semester. Divided by N, which is 4, to the N times T. Well, it says he wants to put it in the account for 6 years. That's my T. All right, well, now we're going to do a little work, but it's going to be a little different. We're still going to work the inside always. So we do the inside of the parentheses, 0.05 divided by 4, enter, plus 1. Now, if I do that, I get 1.00625, and then to the 24th power. That 4 always ends up looking like a 9. There we go. Now, take this number, right, inside the parentheses, to the 24th power. Okay, if you put that into your calculator, what I see in mine, like I said, I take it out very far, is this. Okay, we did this with simple interest. It just doesn't look as simple. But you want to solve for P. Then that means I need to divide, both sides by this long decimal. Okay? But that's what we're doing. We want to figure out what he needs to be putting in every single quarter for the 6 years. Take 30,000 divided by that number. And then you're going to round to the nearest dollar. So in this case, what he would need to invest in, and again, we round to the nearest cent, would be $25,833.30. So that's what would need to be invested in order to have that $30,000 after 6 years. But again, that's a low interest rate. It's only compounded quarterly. So those are things that would need to be taken into consideration. I always say shop around or work with a financial advisor. All right, we have one more example. You decide to invest $8,000 for 6 years, and you have a choice between 2 accounts. The first pays 2.5% per year compounded monthly. The second pays 2.49% per year compounded continuously. So we're going to talk about continuously. Which is the better investment? All right, so this is going to be a little new with some of this. Well, with part B, option 2 for sure. Option 1. This is, again, we're using this formula still for this part. So A equals, for option 1, P times 1 plus R over N to the NT. Option 1, A equals, now he's going to invest you're going to invest, not he, you, $8,000 times 1 plus the rate, option 1 is 2.5%, so 0.025. Compounded monthly, so that would be 12 times a year. And that would be 12 times, and it says that we're going to do this for 6 years. All right. Oops, forgot to put that up there as I'm talking. Okay, so this part is not new as far as what we've been doing. Do inside the parentheses first. So take the 0.025 divided by 12 plus 1. We get 1.002083, and that would be to the 72nd power. Now, let's try to do this in one step. If you have a scientific calculator, you can say 8,000 times this number to the 72nd power. Usually on a scientific calculator, what you're looking for, and let me just mark it on here. Typically, what you're looking for is like an x to the y key. Sometimes that's what you'll see. And so you put this number in first, click on this key, and then put the 72. If you have a graphing calculator, then a lot of times you're looking for what looks like a caret key. That's what we call that. So you would put this number in, click the caret key, and then 72, which would take it to the 72nd power. So many calculators are different, but those are just two examples that I commonly see. All right, we're going to keep going. So I'm going to do this all in one step. Put it all in your calculator and round to the nearest cent, and we get $9,293.22. All right, this is option 1. I'm going to go over here. This one's going to be different, and I'm going to tell you why. The key word was continuously. I did not go over that at the beginning, so I was going to wait for this one. When it's compounded continuously, this is not daily, this is not monthly, this is on a continuous basis. Different formula. And this is going to be a key. This is why we need scientific calculator for this. It's going to equal P times E to the RT. We're using this formula because of that key word, and it's the only time you're going to use that formula is when we're talking about continuously. Okay? Let me show you how we plug it in. We would say A equals 8,000. We don't do anything with the E. That's actually it's on our calculator. Let me just say that. It's a button on your calculator. But now to the R. The R is 2.49%, so it's 0.0249 times T, which is still 6. We're not changing that. All right. We can't do anything yet until we take care of this part. So let me just kind of show you what we're doing. You're going to take E. Well, if you want, you can do this first. That's up to you. You can always multiply that first and then take E to that. But here's the thing. You're going to want to do this first on your calculator. There is an E button on your scientific calculator. It should say, like, a lot of them just say E to the X. That's the key you're looking for. You're going to click E, and then your X is the exponent. So E to the 2.0249 times 6. So that's the first thing you're going to do. When you click the E button, okay, and you take it to that power, what you should get is something like 1.161137. If you're not seeing that, try this again, but just look for that key on your calculator. From here, now you just multiply it by 8,000. That we can do. That's probably the easier part. And we get $9,289.10. So if we were looking, if you were doing this research, because remember in the previous problem I always say do your research, you would want to choose the account that's going to give you the better interest rate. Now, it's not a huge difference, but in time it could be. So option A really would be the winner for this. All right, well, thank you for joining me today.